Hey everyone, it's that math magician, and on this video we're going to take a look at linear equations, and we're going to see how we can relate tile patterns to linear equations. So in this video you're going to see 3 different examples of a set of tile patterns, and we want to be able to identify what's the growth rate and what's the starting point. We can come up with those 2 key terms there for each tile pattern. We'll be able to come up with our equation. So let's go ahead and jump right into our first example of a set of tile patterns where we hopefully can end up with an equation. Now we see here we have some tiles arranged in figure 1. We see that we have some more added in figure 2. And then in figure 3, even more have been added. And the first question we want to find out is, by how much is tile pattern A growing? Now a nice way to identify how your tile patterns are changing is to actually shade in the new tiles that are being added. Here's what I mean by that. I have figure 1 here, and I see figure 1 has 1, 2, 3, 4, 5, 6, 7 tiles. And I see that they have 2 tiles here on the right side and 1 tile here on the left side. Well, as I move over to figure 2, I see that now instead of just having 1 tile on the left side, they now have added a new tile to that side. So what I'm going to do is I'm actually going to shade in that tile there as a way of representing that that tile was added to that left side. The same thing can be said about the right side as well. I see over here on figure 1 we had 2 tiles, but with figure 2 we have 2 additional tiles being added here. So again, I'm going to shade in those tiles to represent that in total, we're adding 3 tiles from figure 1 to figure 2. 1 tile on the left, 2 tiles on the right, for a total of 3. Now let's see though, does that pattern hold up when we go to figure number 3? And as I look at figure number 3, again I see that I have my 2 original tiles here from figure 2. But again, they've added a tile to the top of the left side, just 1 tile, and on the right again they have added 2 additional tiles. So I'm seeing this pattern continue where they're adding 1 tile to the left, 2 tiles to the right. In total they're adding 3 tiles. So when I go to that question over here to the left that says, by how much is tile pattern A growing, I can see here that we are adding plus 3 tiles as we move from one figure to the next. And we can see that, and it might be helpful to see this, if we go and shoot now over to our table here. And if we're looking at our table, the table here, the X values represent the figure number. I see figure 0, figure 1, figure 2, figure 3, and figure 4. Y here represents the number of tiles in each figure. Well, in figure number 1, I see that I have 1, 2, 3, 4, 5, 6, 7 tiles. So for 1, I'm going to write that my Y, or my output there, is 7. For figure 2, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles. So when X equals 2, I know that Y equals 10 for the 10 tiles. And again, when I go to figure 3 here, it might seem redundant to count these out, but if I do, I'll end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 tiles. And so what's really important for you to understand is that we know that we're growing by 3 tiles, but if I represent these tile patterns as a table, it becomes a little more clear that as I move from the figure 1 to figure 2, and from figure 2 to figure 3, I can clearly see that I'm adding 3 tiles as I move from one figure to the next. We started with 7 tiles, I added 3, so now I'm at 10. I added 3 more, so I'm at 13. Now I don't even know what figure 4 is. There's not even a space for us to draw figure 4. But I think I can deduce now what the amount of tiles figure 4 will have. Since I know I'm going to be adding 3 tiles from whatever figure 3 had, and figure 3 had 13 tiles, I know that this pattern will continue, and I'll add 3. And so I know that figure 4 will have 16 tiles in total. And so the table is just a great way of organizing our data points so we can see clearly as we move from one figure to the next, we are adding those 3 tiles. Now the next question on the left side says that how many tiles does figure 0 start with? And you'll notice that figure 0 here is blank. We don't have the diagram drawn here, and we're missing it, and we want to figure out how many tiles start with figure 0. Well, what might be helpful for us is actually to refer back to our table. If we look at that table, we know that figure 0 is unknown at this moment. We don't know how many tiles are in there. But what we do know is that whatever that amount was, we added 3 tiles to get to figure 1. So now we can sort of work backwards as we go through that table. I know that figure 1 has 7 tiles. I know I'm adding 3 to some number to get 7. So I know then that figure 1 must have a total of 4 tiles. 4 tiles because 4 plus 3 is going to give us our 7 tiles in figure 1. What might be even helpful for you further is that as I shaded in the tiles that were added, I can look at figure 1 and I can realize that I tend to be adding 1 tile to the left side. So that means figure 1 was also adding this 1 tile to the left side. And for the right side, we kept adding 2 as we moved through, which means that for figure 1, these must have been the tiles that I added. And now you see those original 4 tiles there in the middle that are actually going to make up what figure 0 was. Again, we know that figure 0 has 4 tiles, and now we can see clearly just how it was arranged. Because that pattern of adding 1 to the left, 2 to the right, is still holding true. So how many tiles does figure 0 start with? It starts with 4 tiles. Now the final question there says to write the equation for the pattern in y equals mx plus b form. I hope you can remember that when we're dealing with the equation y equals mx plus b, m here represents what we call the slope, or in other cases we call it the growth. So m in this case is representing how our tile patterns are growing from one figure to the next, where b is representing our starting point, or our figure 0. And so b represents the number of tiles in our figure 0. So when this question asks us to write the equation in y equals mx plus b form, it's really asking us to determine what is the m value and what is the b value. Well, m refers to slope or growth, and we know that our tile pattern here is growing by 3 tiles. So I know that m in this pattern is going to represent positive 3. Positive 3 because that is the growth rate for this tile pattern. Now what I need to find out now is how many tiles are in figure 0, or how many tiles we start off with. We've already identified it that it's 4 tiles, but if I'm also looking at my pattern here in the table, I can recognize that when x is 0, we start with 4 tiles. And wherever x is 0, that is representing your b term, or your starting place. So to finish out this equation, I have y equals 3x plus 4. 4 represents the number of tiles we start with, where 3 represents our growth rate. And that is the equation that matches pattern A. Now we have one final question that we want to answer, and it says it right here. How many tiles are going to be in the 100th figure? Now, by no means do we actually want to draw out figure 1, figure 2, figure 3, and then figure 4, 5, 6, 7, 8, 9, 10, all the way to 100. No one wants you to do that. What's really nice is, though, is that we have that equation there. Y equals 3x plus 4. And we can actually use that equation to help us figure out how many tiles are in the 100th figure of this pattern. So all I have to do is take that equation, y equals 3x plus 4. But instead of writing x here, I can instead substitute in the 100. Remember, x here is representing the figure number. I'm interested in the 100th figure, so I'm going to plug in x for 100. So I now have an equation where it says 3 times 100 plus 4. I think I can now determine how many tiles are in the 100th figure. So 3 times 100, that makes 300. We still have the plus 4. 300 plus 4, we end up with 304 tiles. Isn't it so much easier once we're able to determine the equation that matches the pattern for us to find the 100th figure? And really, now that we have the equation, we can find any figure number we want to. We could find the 50th, the 70th, the 200th, the 1000th, the 1 millionth figure number. Really, any figure number in this pattern is fair game for us because we have the equation. We just have to plug in the figure number in for x. So that's how we use our patterns to develop linear equations. Y equals mx plus b. Remember, m is our growth, b is our starting point. So now let's go ahead, and that we have this example under our belt, let's go ahead and look at example number 2, where we see we have a brand new pattern letter B here, and we want to see if we can do the same steps to determine the linear equation for this pattern. And so we're going to start this process all over again, and hopefully it'll make a little more sense for you as we work through this. The first question says, by how much is tile pattern B growing? Well, again, I see figure number 1 here, figure number 2, and figure number 3. And I'm going to do the same process that I did in the earlier example where I shade in the tiles that were added. So I'm looking here at figure number 1 and I can see figure number 2 here. And it looks like the pieces that they added here are on the bottom. It looks like they added actually 2 tiles there to the bottom. And what's nice is once you shade in the tiles that were added, you're always left with the figure from the one before. So I see that they added 2 tiles there, and I think that pattern is actually going to hold up when we go to figure 3. We see that we are left with what figure 2 looked like, and they just added 2 additional tiles to the bottom. So how much is tile pattern B growing by? It's growing by plus 2 tiles. And now we have to figure out how many tiles does figure 0 start with. So again, we could jump to the table, or an easier way might be is that I know that I'm still just adding 2 tiles to the bottom. So that means for figure 1, 2 tiles were also added to our figure 0 to get figure 1. And once I draw out or shade in those tiles that were added, I'm left with the original figure 0 here. And now I can see that figure 0 ended up being 3 tiles arranged just like that. And every time we moved to the next figure number, we kept adding 2 tiles to the bottom. So how many tiles does figure 0 start with? I think it starts with 3 tiles. And if we want to, again, double check our work, let's go to the table and fill in the information that we know. We see figure 1 started with 1, 2, 3, 4, 5 tiles. I see figure 2 started with 1, 2, 3, 4, 5, 6, 7 tiles. And figure 3 started with 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. If you were unsure about whether or not our pattern was growing by 2 tiles, well, look at our table now. I think it's a lot more clear now that as we go from 5 to 7 to 9, that we are adding 2 tiles each figure number. Which then means that figure 4, after I add 2 more tiles, figure 4 would have to have 11 tiles as well. And since I know figure 1 has 5 tiles, and I was adding 2 tiles to figure 0, that then means that figure 0 must have had 2 tiles as well. I mean 3 tiles. So there you go. We know that this pattern tile is growing by 2, and it starts off with 3 tiles. I think that's enough information for us to determine the equation for this pattern written in y equals mx plus b form. Well, the growth here is 2 tiles, so we're going to change m to be a positive 2. So we have y equals 2x plus how many tiles we start off with figure 0? We started off with 3 tiles. So there is our linear equation, y equals 2x plus 3, that represents this tile pattern here. And again, we now want to see, can we figure out the 100th figure tile? How many tiles will be in that 100th figure? All we have to do is take our equation and substitute 100 in for x, and we'll be able to see how many tiles are in our 100th figure. Again, we don't want to have to draw out all of those figure numbers. Instead, our equation will allow us to do that. So 2 times 100 will leave us with 200 plus 3. We end up with 203 tiles in figure 100. So again, just to recap, in order to come up with our equation here, we need to determine our growth, where we were adding 2 tiles each time, and our starting point, or figure 0, we started off on this problem with 3 tiles. So then again, I'm going to zoom out so we can kind of see the similarities between pattern A and pattern B. And we see that they did have a constant growth. For A, we added 3. For B, we added 2. And they had a different amount of starting blocks for figure 0. But no matter what, we still were able to figure out what the equations were for pattern A and for pattern B. I got one more example for us to do, and that is pattern C. And for pattern C, we're going to switch it up a bit. For pattern C, I'm going to tell you that the growth of a tile pattern C is represented by the equation y equals 3x plus 1. So off the bat, we are starting off with the equation. We know that the equation is represented by y equals 3x plus 1. And we don't even have any tile patterns here to look at or to reference. We're going to have to use this equation to help us build the table and then hopefully be able to figure out the 100th figure tile. So, how many tiles is pattern C growing by? Well, looking at that equation and remembering that the term next to the x variable always represents our growth or our slope, I know then that this tile pattern for C is going to be growing by plus 3 tiles. I know that because the number on the x, the number with the variable, is 3. And how many tiles does figure 0 start with? Well, I know that the b term at the end of this equation always represents our starting point, or in this case, our figure 0. So I know figure 0 starts off with 1 tile for pattern C. Now let's jump to our table and let's fill in our table with all the values that we know. I know that the 0 term here is going to be 1. It's 1 because we're starting off with 1 tile in figure 0. Our equation told us that. Now I need to fill in the rest of these numbers here for the tiles in each figure number. And I know that as I move through that table for the y values, we are adding 3 tiles for each figure number. So if I start off with 1 in figure 0, figure 1 will have 4 tiles. Figure 2 will have 7 tiles. Figure 3 will have 10 tiles. And figure 4 will have 13 tiles. And we see again that we have that starting point of 1 tile, and we're adding 3 tiles as we move through. Now, for the question here, underneath the table, it says, where do you look in the table to see the growth and the starting value? Where I'll start with the easy one. The starting value is your 0 term. So I'm going to go ahead and make a little note here that the starting value, that is our 0 term. Whatever the 0 term is in the table, that tells you what your starting point is. And to find the growth, Well, the growth is just how your y row or your y column is changing. That's how you see that in the table. The growth is the change in y. And we see that that change in y is growing by 3. Now for the final problem here, we know our equation. I think we can find how many tiles are going to be in the 100th figure. So I'm going to go ahead and use that equation. Y equals 3x plus 1, but instead of using x, I'm going to plug in 100 because we're interested in the 100th tile. Well, y equals 3 times 100. That ends up being 300 plus 1. We know that the 100th figure has 301 tiles. And you might be thinking, questions 3 and question number 1, or patterns A and C, are actually very similar. You'll notice that they both have the same growth pattern. They were both growing by 3 tiles. The difference here, really the only difference, is how many tiles they started off with. Pattern A started off with 4 tiles, whereas pattern 3 started off with only 1 tile. But it's just important for you to recognize that when you're developing your linear equation in the form y equals mx plus b, m is always going to represent your growth. The letter that goes, or the number that goes next to the x variable, that always represents your growth, and the b variable, the b term that's at the very end, the constant on its own, that is figure 0. All right, everyone, it's that Math Magician, and I'll see you on the next video.